Possibly.
It's in the air.
All right. So practice test 3 looks just like the other ones. Your test is Friday?
Yes.
Because I don't see you tomorrow. Okay? So here we go. We do have office hours on Friday though. All right. So here's our problem. Step 1.
Factor.
So how do you suggest factoring now? What do you want to do?
X minus 5, X minus 1.
Alright, so I'm here in Scout, X minus 5, X plus 1. I'm gonna double check that. I always double check my factoring, especially on this problem, because it's worth so many points, and I don't wanna screw that up. So X squared plus X minus 5X minus 5. Everybody knows that to check your factoring, you do first times first, outside terms, inside terms, last terms. And then see if that adds up to this. And it does, because that gives me -4. So I'm good. Top is done. All right, what about the bottom? Jacob?
2x minus 1x plus 1.
So he says, look at that. I can take a 2 out. Do you see that? And if you take that 2 out, what's left? The difference of squares. So 2x minus x plus 1. We are factored. And if you are struggling, I suggest you go back and refactor these. Factor them over and over and over again until you get comfortable with it. All right, ready to start graphing and filling things in. What do you notice?
Cancel.
We're going to have a hole because we're going to be able to cancel, right? So I am going to actually be graphing x minus 5 over 2x plus 1. Remember, when you take out your GCF, you have to keep that number. Okay, don't ignore the 2. Okay.
On the denominator on the bottom, could you just simplify it and put 2x plus 1, or do you have to keep it in parentheses?
Well, if you distribute it, it would be 2x plus 2.
Oh, yeah.
And you can do that, but then it's harder to see where the asymptote is.
Oh, yeah.
It's easier to see that the asymptote is a -1.
Isn't it supposed to be a -1?
It is, because I canceled out the plus 1. Thank you, Jackson. I canceled out the x plus 1, so that's what's left. Thank you. All right, now what?
There's a vertical asymptote at
There's a vertical asymptote at
x equals 1.
x equals 1, because that's what makes my denominator 0. All right.
Horizontal at 1/2.
A horizontal asymptote at y equals 1/2. Because to find the horizontal asymptote, we do this, right? We box them in. So that gives us 1/2. We're going to have a hole. We knew that because why? How do we know we're going to have a hole? Because we cancel. And where will the hole be? X will be -1. Everybody look at that. We canceled out x plus 1. So the hole's at -1.
Plug it in.
Comma. We're going to plug that in. Where are we plugging it in at? Right here for x. Right here. So -1 minus 5. 2 times -1 minus 1. Putting in -1 for the x's. So my top is -6. And what's the bottom?
2.
Well, -2, -4.
Wait. Oh, my bad. My bad.
-1 minus 1 is -2 times 2.
That's on me.
So that's 6 fours, 3 halves. So I have a hole at 1 1/2. Negative 1 3/2. Okay? What else? You gotta fill in all those blanks and put all that stuff in your graph. So what do we still need to find?
X-intercept.
X-intercept, and where does the X-intercept come from?
From the top.
The numerator. So X is 5, 1, 2, 3, 4, 5. Alrighty. And then I need a Y-intercept, Declan.
That would be 5/2.
I'm gonna let X
Or
be
X equals 0.
0. So if I plug 0 in, I get negative 5 on the top and 2 times negative 1 on the bottom. So that's positive 5/2 or 2 1/2. So 0 5/2 or 0 2 1/2. That is your Y-intercept. Now, all your blanks should be filled in now. We have found everything. So now it's time to just make a picture.
Reciprocal.
It's going to be a reciprocal function. And because we got points up here, it looks like it's gonna look like that up here. Would you agree with that? And then down here,
Opposite down
there it is. That is worth a ton of points. Practice it if you're uncomfortable with it. All right, are we good? Ready to move on? I'm gonna have to erase this to go on to the next problem. All right, now we have a page of inequalities to solve. So what do we have to remember with our inequalities? When you see that less than or greater than symbol, what do you need to remember?
Everything needs to be on one side.
Everything needs to be on one side. In other words, you need a 0.
and number
So
line.
we'll, and a number line. So we'll subtract the 2x over. I know I'm gonna use a number line. In order to figure out where the dots are gonna be on the number line, though, I'm going to need to factor. So how does that factor?
And it's parentheses X minus 2.
Take out
GCF.
the GCF, greatest common factor. So both of these have an X. So if I pull it out, I'm left with X minus 2. Right?
Yep.
Where are the dots?
2 and 0.
0 and
Two.
2.
Positive 2. And shaded.
They are both colored in dots. And now what?
Pick a number.
Yep, test a number.
0.
And I like 0, but I can't use 0 because remember, you can't use a dot.
1.
So I'm maybe 1. 1's fine. So 1 times 1 minus 2 is 1 times negative 1. Is that less than 0?
Yes.
Yep, so shade it, problem finished. 0 to 2. Remember, we're shading every other section, so if we shade the middle, we're not shading the outsides, so we're done, that's it. Easy peasy.
Wait, I don't think how you shade the middle,
Because we tried 1, and 1 made it less than 0,
I was thinking shade the
so you shade it when it works. When it gives you what you wanted, less than 0, you shade it. Now, that one was a piece of cake compared to this one. This one's a little more work, but it starts the same way because it's an inequality, so I gotta have a 0. I gotta have a 0, and then I'll get a common denominator. Because This is a fraction. Now I've got two fractions in here. All right, so I want to say one more time. When you see that symbol or that symbol, you get 0 before you do anything else. Okay? So before you do anything else, get a 0. Then do whatever you need to do. So Alex said, okay, I'm going to get a common denominator. Well, that's just a 1. So won't my common denominator just be x plus 5? So I'm going to add, not add, but multiply an x plus 5 here and an x plus 5 here. Now my denominator I must keep because it's going to give me a dot on the number line. I'm going to use a number line. This is an inequality. And the denominator is going to give me a dot. I must keep it. And then my numerator, there's one of these in the homework, and we gotta be really careful. This is always gonna be a minus because we're subtracting it to get it over there, right? And so when you do this distributive, minus 2x minus 10, it's real easy when I'm standing up here talking about it. You gotta catch that on your own, okay? All right, what's that numerator look like then? Negative x minus 11. When you combine like terms, gonna get a dot from the top and a dot from the bottom. The bottom dot's easy. Where's the bottom dot? Negative 5. This confuses me.
Can we take out?
So what I would do is just set it equal to 0, figure out what makes it equal to 0. Just set it equal to 0 and solve it. So it looks like that other dot is gonna be at negative 11. So I have a dot at negative 11 and a dot at negative 5.
Both open.
Both open because of the symbol in the problem. There's no coloring anything in this time. Can I use 0 this time?
Yep.
Yep. And 0 on my number line would be out here. So if I put in 0, I get negative 11 over 5, which is not bigger than 0. So I will not be shading here. Instead, I will shade here. And my answer is everything from negative 11 to negative 5. Everyone good? All right, one more inequality down there at the bottom. What's new and exciting about this one? It has an exponent. I mean, a quantity squared, a parenthesis squared. So what that means is when I get my number line here, I'm gonna have to check every single spot. I can't do my alternating thing I've done. I have to check every single spot. The good news is, I already know where the dots are. Where are the dots?
Negative 2.
No.
Yeah, negative 1, sorry. And positive
Negative
2.
1 and 2. And notice I put them in order on the number line. They will be open dots. And now I just start picking numbers. So let's pick 3. 3 minus 2, 1, squared is 1. 3 plus 1 is 4. Is 1 times 4 bigger than 0? Yep, shade it. I'll use 0. 0 makes negative 2 squared, that's 4. 0 makes 1. 4 times 1, is that bigger than 0? It is, so that also. All right, how about negative 2? Negative 2 minus 2 is negative 4, squared is 16. Negative 2 plus 1 is negative 1. 16 times negative 1. Bigger than 0? Nope, not shaded. So this is what I'm shading. Or this is what my answer is. Everything that's shaded. Be careful. Can we say negative 1 to infinity this time?
No.
No, because it has a gap in it.
It's negative.
So you're gonna have to do each section. You can only combine them if they're connected, solid all the way, but they're not. So we can't do that. We're gonna have to say negative 1 to 2, or 2 to infinity. Now, if you can remember yesterday, of course, we had a problem just like this, but the dots were filled in. So when we did the shading, it amounted to the whole thing being shaded. You catch that? It's kind of a little fine point.
Open circles are like
All
holes.
right. What?
The open circles are like holes.
Yep, they are, exactly. Good way to think of it, yeah, okay. I thought I was done with inequalities, but I'm not. There's one more here, so we're gonna do this one. It's not lunchtime yet, so quit salivating. Notice how I started. I started by moving everything
One side.
over, because when I see a symbol like this, I must have 0. So the first thing I do is make a 0, get a 0, okay? All right, what are you gonna do now?
Synthetic division.
Well, we can't factor, so
Synthetic.
synthetic method.
Yeah, so I know, I love it, I totally love it. There's some wheels are turning out there. First thought was, let's do some factoring, but then it was like, oh wait, that ain't gonna work. Because if you factor by grouping, you have to be able to end up with the same parentheses. Factoring something out isn't enough. You have to have the same parentheses. We don't. So I heard synthetic division. Factors of 24? Oh, there's a lot of them.
24, 12,
But pick one of those and try it. So what do you want to try?
32.
1. I don't think 1's gonna work, but let's just double check because I have been wrong. Did it work? 2? I heard a 2. Ooh, I think we got one there. I think 2 worked.
Negative 3. Oh, sorry. Negative 0.
Yeah, and there's more numbers that work. I just happened to take I did this one, and that's the one that worked for me. We're all going to have exactly the same answer when we're done. So if you're going in a little bit different order, that's fine. What do I do now though? Let's go with mine. I got a 2 divided out. What do I do now? X squared minus x minus 12, right here. Right? Quinn, that's what you were helping us with this morning. That's what we do, right here. And then what do you do with that?
Factor.
Factor that carefully. X
Minus 4 plus 3.
minus 4 plus 3.
Yep.
I'm gonna double check that. Yep, you got it. Now, why did you factor?
Get points on that.
To know where to put your dots, right? But be careful. this problem has 3 dots.
Oh.
How do you know, Mrs. Ford? Because it's x
Q.
cubed. There are 3 dots. Clearly, one of them's at -3, one of them's at 4.
One's at 2.
Where's the other one is right here. No,
Ah,
two.
two.
This number gave me 0. So that's the number that goes on the number line. So I have -3, 2, and 4 on my number line.
And close circle.
-2, or -3, 2, and 4. Right?
2 with the x too.
Just wrote all over myself. Okay? And they will be closed in dots. Now, one more thing to be careful of. If there's 3 dots, there's gotta be 3 factors, right? So what's the factor?
X minus 2.
X minus 2.
Okay, now I'm getting it.
When you put a number into the parentheses or bring it out, its sign changes. So if the dot's at 2, doesn't it make sense that the factor would be at x minus 2? Okay? So now we're going to,
Pick a point.
Check a
Two
number?
numbers.
and I think I'll just go ahead and use my 0, it's right here, my 0. So 0 minus 4, -4. 0 plus 3, 3. 0 minus 2, -2. Now multiply all those together. -4 times 3 times -2. Will that answer be bigger than 0?
Yes.
Yes. So we're gonna shade that section, cause it worked.
No square.
So what else gets shaded? Not this,
Pass the 4.
not this,
Put the out of one.
this here.
There's no square.
So my answer, -3 to 2, or 4 to infinity. That's a big problem. Does anybody have a question about one of the steps of the problem? Remember, this was our first try. So this is not part of the answer. This was our first attempt. It didn't work out. So then we went on and guessed again. Okay? All right. Now, the next one is not an inequality. It's an equals. So do not get 0. Do not draw a number line. Somehow solve this equation. So how shall we do that?
Common denominator.
So what common denominator do you want to use?
6x.
I heard 12x, I heard 6x. They both will be fine. Use whatever you want to use. If we go with 6x, then this one needs times by 2x. This one times by 6. And this one by x. So multiply. So 4x, this is all multiply here. Okay? So 4x plus 24 equals 5x. So that's an easy one. Does x equal 24?
Yep.
I want to show you something real quick. Somebody wanted to use 12x as the common denominator. So if I were going to use 12x, perfectly fine, I would multiply this one by 4x, this one by 12, and this one by 2x. Would everybody agree with that if I decided to use 12x? So then my equation is 8x plus 48 equals 10x. So 2x equals 48, and what does x equal? Same thing. It doesn't matter, just get a common denominator. All right, one more and then we're on lunch. Letter F. what should I do, maybe as I'm copying this problem down, factor that middle denominator, and it's gonna factor into x plus two, x minus two. Would you agree with me up to this point? What do you wanna do now?
Multiply x plus two by x minus two.
We gotta make our denominators match. So this one needs an x minus two. And that one needs nothing. And this one needs an x plus two. Everybody on board? Now they all match. So x squared minus 2x, distribute here, minus 1 equals 2x plus 4. Now what? Get it equal to 0. So I'm going to subtract 2x and subtract 4. These do not cancel. That makes x squared minus 4x minus 5. Factor that. So what are my answers? X equals 5 or x equals -1. Now these are the kind where you have to pay attention and make sure these aren't extraneous. These two numbers do not make anything 0, so they're good. These are both answers to the question. Okay? All right, you need to be back in your seat at 25. Back in your seat. Wait. Yeah, that's right, 25. Back in your seat at 12:25. Yes.
I can't be here Friday.
Why is that, Mike?